Hi everyone. Today I'm going to present you some Windows Ninja stuff. So just to have a quick idea, how much people worked on Active Directory in the audience? Who's been pointing them? Yeah, great. I'm going to show you some deep techniques about pointing Windows Active Directories and Windows itself. The thing is, I knew that not everyone is aware of how Active Directory works and what you can do with it. So I'm going to do a quick introduction to the basic stuff. We'll see what is the Active Directory, what is LSAS, how does it work, and then I will show you how to hack the things. So first things first, my name is Aurélien Chalot. You may know me on the internet as Deft. You may have seen me during the hack in 2022 and 23, and hopefully in 2024 as well. I'm a hacker, sysadmin, and security researcher for Orange CyberDéfense. Well, optionally, I do love calisthenics and philosophy. And I'm one of the members of the IdenSec crew, which you may know as well. So yeah, just to give them a quick thumbs up if they see the live. Okay, so let's start with the interesting things. What is Active Directory? Basically, Active Directory is an annuary that contains information about resources of an enterprise. So these information can be computers, servers, printers, shared folders, files themselves, and users. So pretty much the idea is to have everything under control on one tool, which is the Active Directory tool. So yeah, I put some screenshots about the servers and computer stuff and the groups and users you can find on an Active Directory. If I had to draw something, a quick schema of what an Active Directory looks like, I would say it looks pretty much like this. So you've got the domain admins, which are the people that have the most privileges on the Active Directory. These are the people you want to target while doing an internal assessment. You have the domain users. This is basically you and I. When I plug my computer into the internal domain of a company, I'm a standard user. I've got standard privileges. I can access some files, send mails and stuff, but I'm not powerful. And we have the computers, the servers, which I already told you about. The thing is, all these resources are managed from a specific server that is called the domain controller. This is the middle piece. This server is basically the most important resource you have, since it stores the NTDS database, which contains all the information from your Active Directory, including your users' passwords, which are stored as hashes, which we called NTLM hash. So you don't want anyone to be able to access the domain controller, and you don't want anyone to access the NTDS database as well, because it contains pretty much everything. When you do an internal pen test, the main goal is to compromise the domain. You might have guessed that. And as I told you, compromising the domain means being one of the domain administrator. There are multiple ways you can do that. So I showed you three of these ideas. So first of all, you can compromise users' accounts, which uses weak credentials. So for example, let's say you have the administrator, which uses the password, or whatever, Asiati1234. If you can't find these accounts and the password it uses, you will be able to compromise the account as well. You can exploit default Active Directory configurations, and you can exploit vulnerable services and servers. So you may have heard of Eternal Blue in 2017, which was used to compromise the SMB protocol and gain access to any resources on the internal company as the NT system account, which is the higher account in terms of privileges on the Active Directory. Basically, the classic scenario you will find as pen testers is the following. So you're going to be able to compromise some servers. On it, you will be able to retrieve the content of both the LSAS process and the SAM database, which I'm going to talk to you about in a few seconds. Basically, what you need to know at this point is that these processes and databases contain secrets that you can reuse after. And the thing is, with these secrets, you will be able to reuse them on other computers and servers and potentially compromise some of them. At some point, using this methodology, you will be able to compromise more privileged accounts and bounce from them to even higher privileges accounts. So, just to give you a quick infos about what the SAM, LSAS, and NTDS database are, because we're going to need them. Let's start with the NTDS database. So I told you NTDS is the database that contains users' passwords, so the hashes, not the clear text passwords. It is located on each domain controller in the system32 directory. Basically, when you've got a computer that is linked to the Active Directory, what's going to happen is when you log in, the LSAS process is going to send the authentication information, to the domain controller. And the domain controller is going to check into the NTDS database whether the credentials are correct or not. When the computer is not linked to the Active Directory, so basically your computers as a student, maybe, you have, still the LSAS process, which is still there, but it won't send any information to any domain controller as there is no domain controller, or whether it will use the SAM database in which is stored locally on your computer in the registry IVES, the following one, and it will check whether or not the credential is correct as well. So the thing is, even if you're not, whether you're linked to Active Directory or not, there is one process that is important, and this process is LSAS. LSAS stands for Local Security Authority Subsystem. And sorry, I forgot to translate that slide. But basically, this is the process which is handling the authentication on Windows. And you will find it everywhere on Windows. There is no Windows operating system that doesn't have the local system, the local security authority process. So as I mentioned, this process is very important. Why? Because it holds all the secrets you need to authenticate yourself on Windows, both locally or remotely. And if it holds these secrets, what you want to do as a pen tester or hacker is to dump the content of this process, since there are, the credentials inside. And once you've got access to these credentials, you're gonna replay them. So this is what I showed you there. Dump the LSAS process, access the credentials of the people who are logged on the computer, reuse the credentials, and hopefully you will find some privileged account. So I'm going to show you how it works. I'm going to show you quite a few demonstrations during this video, this conference, sorry. Basically, the configuration of what I'm going to show you is the following. You've got the DC, which is the domain controller. This is the masterpiece of the domain, I told you. You've got some server, server 2019. We don't care about it, actually. The only thing we need to know is that we compromised this server. So we have got the anti-authority system account on it, which is the highest privilege account on the domain. And we know that an administrator of the domain is connected on it. And what we want to do is to be able to usurp its identity in order to be able to run commands as the most highly privileged, as the highest privileged account of the domain. Got it? So, for the first, I'm going to show you one famous tool which is called Mimikatz. You may have heard of that already. This is a tool that was developed by a French guy called Benjamin Delpy in 2012, 13, 14, 15, I don't remember exactly. But basically what it does is it allows you dumping the LSAS process and obtaining the credentials that are stored in it. So, hopefully you will be able to see everything I want to show you. Basically, you've got, on the left top, you've got the server we already compromised. On the left, right, you've got the domain controller, which we want to compromise. And at the bottom, we've got an access to the left server, so the server 2019, as the NT system account, and we're going to use Mimikatz. So just to mention it, I specifically disabled the antivirus on this because Mimikatz is a highly used tool which is signed and blocked by most antiviruses. So as you can see, I'm launching Mimikatz. And then I'm going to use a command which is called securl assay, login passwords, which is going to dump the content of the LSAS process and retrieve the passwords. So let me just scroll back. Here you've got it. So we can see that indeed we have someone authenticated on the server, which is called, the user is called administrator. And we can see that there is the NTLM hash of the user, which is basically the password as a hash. And on Windows, having the password in clear text or the hash is the same thing. So what we're going to do next is connect to the domain controller, which is the IP 2002.21, as the administrator using the NTLM hash. And as you can see, I am successfully connected, and most of it, I've pawned the computer. And if you know CrackMap exec, or now net exec, you may know that having this mentioned means that you have the local administrator rights on it. So you've got the domain. And I think that's all for that demo. Let me see. Yeah, okay. So you've got the ID, the overall ID of an internal plain test, compromise an account, a server, dump LSAS, replace the credentials. Hopefully you will find the domain, admin administrator, replace the passwords on the domain. Now the thing is, I specifically told you that I disabled Windows Defender because I didn't want it to be harassed by the antivirus. So we've got a problem here. In internal pen test, you will not hopefully see computers that are not protected by any antivirus or EDRs, which is the problem. Now the answer is, if you're not able to dump the LSAS process because it is protected by an antivirus, what you can do is play with what we call the Windows tokens, or what we call the Windows internals as well. So I'm not going to do a full talk about Windows token. If you haven't seen my talk at Le Hack 2022, I highly suggest you take a look at it, or you can, for the non-French people, you can read the blog post here, which is a 30-minute long blog, which is going to explain to you pretty much what I told you already, with a lot more informations. I'm just going to give you a few insights of what the token is and why it is important. So on the Windows, in the Windows environment, what you need to remember is that your identity card is called the token. Your security context is called a token. This token, which is an internal object from the Windows subsystem, specifies a lot of things about you. Amongst these informations, you will find the user to whom it belongs to. So in that case, the administrator account. You will see the groups in which the user is a member of. So in that case, we have the administrators groups. You will find the login SID, which identifies uniquely the user on the system, but we don't care about this actually. And you've got the list of privileges owned by the user on the system. So basically, what you need to remember about these tokens is that they represent you as a user and as well as your privileges on the computer. Now, there are two ways you can get a token. I'm just going to show you the first one, even though I have a slide for the second one. The idea is not to show you the entire things as I told you. When you log into your computer, so you're this guy. When you log using this view, which is called the WinLogon UI, what you do actually is send your password. That's pretty straightforward. As I told you, the LSAS process is going to handle the authentication and check whether the credential you submitted is correct or not. To do so, it will rely either on the SAM database, which is locally, or the NTDS database, which is remotely located on the DC, domain controller. If it fails, well, you've got the logon failure. If it's success, you will be able to obtain what is called a primary token. And I told you this primary token is your identity card. It specifies what you are able to do on a computer or what you're not able to do. Each time you will launch a new process with your account, the process will inherit this token, and as such, the Windows system will be able to know whether Firefox has the right to access some sensitive data on your computer, or if you are able to launch Teams or a malware or whatever. The thing is, I told you, since this token represents you on a computer, if you are able to steal it, you will be able to usurp an identity. You will be able to say, well, I took this token, now it is mine, and I'm going to use it to launch some processes and to, in order to usurp the identity of a guy as well as his privileges. And this is something we want to do as hackers because it will allow us being able to launch commands as other users without touching the LSAS process, which is highly monitored by antiviruses. So this is why I use this meme. The idea is that the administrator is connected on the computer, he's got full privileges on the domain. What I want to do is to steal the token of this guy and use it so that I can launch processes and commands as him. The only prerequisite we need is that we need to have the guy connected to a server that we own. So I'm going to show you this time a demo of what we call an impersonation. So we've got the same setup. The only difference is that on the left top, I enabled Windows Defender, and you're going to see that I will be able to launch commands as the administrator using the impersonation technique. So as you can see, the administrator account is connected on the server I compromised already. I am not the administrator, just to prove you that I'm not lying to you. I am the anti-system account, which is the highest privilege account on the system. And what I am going to do is launch a tool which I wrote in 2022, which is called Impersonate. The first thing it is going to do is to list the tokens it finds on the system. So as you can see on the following output, it says that it found primary token for the anti-system account, the administrator account, as well as other people's, the Windows manager did DWM. We don't care about this one. What we want actually is the administrator account. Why? Because this is the domain admin guy we want to usurp. So now that we know that there is a token for him, a primary token, we know that we will be able to usurp the token, take it, and launch some processes with it in order to usurp the guy. So what I'm going to do is to call impersonate again. I'm going to specify the token ID I want to use to impersonate, the token ID I want to steal, and the command I want to launch. And now if you type the results, you will be able to see that I was able to impersonate the administrator account and launch the whoami command, which results in me being able to launch commands at the domain administrator. And obviously, the antivirus is enabled, so yeah, we won. Basically, we were able to bypass any security and compromise the domain. Now, the thing is, this is quite a known technique now. It's been fingerprinted by a lot of tools. So I'm going to show you new ways of doing this, which will be useful at some point for your internal pen tests. And you will see how broken Windows is. Yeah, well, we'll break it. Our fault. But yeah, the idea is you don't need the clear text password of the guy. You don't need the hash. What you need to be able to is to find ways of executing code from their security context using their tokens. And yeah, as I told you, there will be, I will show you a few ways. The only thing you need to know is that, well, the second thing you need to know is that in order to do so, you will have to dig into the Windows internals. And that is a pain in the ass, to be honest, but it's quite interesting as well. You may have heard of the Windows internals. These are books that describes heavily how the Windows system works. So if you want to understand what I'm going to show you more precisely, I encourage you reading this, although this is quite a heavy read. That's 1,400 pages. So yeah, quite a lot of things. I'm going to show you basically 3 ways you can usurp someone's identity on the Windows operating system. The first one is about the scheduled tasks, and the second one will be relying on the RDP protocol, which allows you accessing remotely a computer. So basically, on any system, whether it is Linux or Windows, you will be able to schedule tasks. So this allows you running whatever tool you want at whatever time you want as well. So you want to do that because mostly you will have to run a backup script, for example, every once in a while, every 2 weeks, every month, whatever. The thing is, when you have high privileges on a computer, you will be able to see that you have the right to run tasks using a following user account. And this is quite an unknown trick, if I may say, because there is some crazy shit here going on. You can simply change the user, which is yours, and say, okay, I don't want to run the task as this guy, as me. I want to run this task as the guy that is connected on the computer. In that case, the administrator. I want this task to be run by the most privileged account on the computer, on the domain. So what I'm going to do is just click on change user and select, well, someone that is connected on the computer already compromised. So this is fairly broken. Yeah, you can do pretty much what you want with that. And so maybe you have heard of NetExec. If you don't know about NetExec, I encourage you taking a look at what it is, because you're going to need that for, well, the future internal pen test you will do. NetExec is an amazing tool because it allows you targeting hundreds of thousands of computers in less than 2 minutes. It allows you doing remote operations on Windows, pawning stuff the fastest way possible. So yeah, this is quite a nice tool. I personally know the guys behind the project. I help them sometimes. So yeah, another big thumbs up for them. Basically, I'm going to, well, what I'm doing here is I log into the computer remotely. I'm listing the guys that are connected on the computer. And as you can see, there is one admin account, the guy I want to impersonate. And then I wrote a module for NetExec that allows you running a scheduled task for another people on the computer. So this is fairly broken. You just need to do the following things. Specify the user you want to impersonate and the command you want to run as them. And as you can see, I am able to run commands as the guy I want to. So now I'm browsing the domain controller, but that's just some stuff you can do if you want to, but it doesn't matter. The thing is, I am able to impersonate anyone on the computer. And that is a technique I overused in the last few months. It is not blocked by any antivirus. It may be blocked by EDRs now, but it's not always the case, and it's broken because you can do whatever you want as whomever you want on the computer. But that's not the most impactful and most interesting trick I've got for you. Now, you may have heard of the RDP protocol, which allows you accessing remotely a computer with graphical UI. The thing is, when you have the access as the NT system account on a server, you will be able to just say, okay, there is the admin guy connected using RDP. I am NT system on the same server. What I want to do is I want Windows to take his window and show it to me. So once again, it is broken because you will be able to just take the graphical UI of the guy you want to impersonate and print it in front of your face on your computer and thus interact as the guy. This is obviously a security thing that Microsoft did not think of. I'm just not going to talk much, pretty much show you I'm going to show you the thing. It's much more interesting. So this technique is called RDP hijacking. So we've got the following setup. On the left is the admin account who want to steal the account, usurp. On the right is me as an attacker. So the first thing I do is I'm connecting using RDP. It allows me browsing the server where you see I'm not the admin account. The first thing I'm going to do is use a famous tool called psexec. So you may have heard of this as well. This is a tool used to manage computers remotely, but also that you can use to elevate your privileges on a Windows system. It allows you going from the local administrator to the NT system account, which is, once again, the most privileged account on Windows. But it doesn't matter. The idea is just, okay, we have the privileges. We know that someone is connected and we want to take this session back. How do we do that? Well, the first thing we need to know is to use the query user command, which is going to show you who's connected and what their session ID is. This is just a digital number. And once you've got the ID, you just need to run a little tool called tscon. You specify the ID you want to steal and the destination. So basically the thing is, what you're going to do is say, okay, I know that the admin is connected on session number 3, and I want that. So what you're going to do is take the session number 3 and print it on my session, which is RDP TCP #5. Now if I click enter, I'm getting access of the RDP session of the admin account. So the things I wasn't supposed to be able to see, now I do. And if I can do that, I can as well, once again, create accounts on the domain, access the domain controller, destroy everything, launch a ransomware, whatever. So once again, we won. And this technique is not blocked again by any antiviruses or EDOs. The only thing is, oops, just like my computer. The thing is, even if it's not blocked, Microsoft realized that it was kind of a bad idea to be able to do that. So they released a patch which is incorporated into the latest Windows operating system, and they provided an update for the older system as well. So during an internal assessment, you may not be able to do what I just showed you, but there is another way you can do that, and that technique is called shadow RDP. So the idea is that even if you cannot hijack RDP session anymore, what you can do is add specific settings into the computer or the server, which says, okay, I'm going to let you decide whether or not you want to be able to spy literally on other people's sessions. So this setting is the following. So you will have to, sorry, I'm going to, yeah, better. So if you modify the following registry key, which is HKLM, software policies of Microsoft Shadow, nice name, you can say the following values. 0 means that you cannot shadow RDP, you cannot access the RDP session. 1 means that you can access it and well, interact with it, but it will notify the user. The second one is the most interesting one, as it allows you interacting with the session without the user being able to say, oh, I don't want anyone to be able to spy on me or act as me. So this is the most broken settings you may set, sorry. And I'm going to show you pretty much what it looks like, because once again, a demonstration is much better than talking stuff. So we've got the same setting, although this time the computer we want to hack is on my left. Yeah, my left. And I am the attacker on the right, for you. So as you can see, I modified the registry key, so I did set the value to 2 to the registry key shadow. Now I'm logging on the computer I already compromised on the left, well, your right. And I'm going to do the exact same thing, query user, take a look at who's connected, what is the session ID I want to hijack, and now that I've got this, I'm going to run a simple tool which is called MSTSC. That is a built-in tool in Windows. So this is legitimately, this guys legitimately said, okay, we will give the people the rights to shadow some sessions. I'm saying, okay, I want to connect to that computer, and I want to shadow that session ID, which is going to be the number 3, which belongs to the admin user. And I want to control the session remotely without the user being able to say, oh, well, I don't want you to take a look at my things. And as you can see, the session opened, and now I've got access to the computer. And whatever I do on the left is going to be done on the right, and vice versa. So as an attacker, I can access the session of another guy. And if the guy wants to show me things, he can show me things as well. So let's say you must be aware of what KeePass is. I hope so. If you don't, take a look at it. It's a database that allows you storing your passwords in a secret, secured way. What I do during my internal assessments or red team assessments is that I use this technique to be able to access the key passes of the guys I target. The reason why I do this is because there are secrets that I need to be able to access to compromise the entire domain. For example, I want to be able to connect to the ESXi server, which holds the VM infrastructures and backups. And that trick is especially useful because, well, once again, there is nothing Microsoft can do to prevent that. The only way you can block this is by monitoring the registry key creation. And well, there is another way, which I'm going to show you, but it is quite heavy and it takes a lot of time to implement. So yeah, basically, how do we prevent such abuses? Because these are not exploits. Yeah, you cannot say that these things are exploits, or whether you can say that these are abuses. Well, there are two ways. The incorrect way, which consists of buying high-cost security products, buying stocks, buying certs, and still get spawned because, well, these products, these people are not going to protect you entirely, although they do a great job. What you need to do is to implement what we call a tiering model. And that is the most effective way of doing such, well, protecting your computers. So basically, this is what the tiering model looks like. The idea is that you're going to, well, how would I say that? Sorry, I'm losing my words. The idea is to, well, cut your domain into multiple parts, which do not have the same privileges. If you take a look at the tiering model on the internet, you will see that there are three levels: T2, T1, T0. The T2 level contains all the user accounts, standard users accounts, and the computers. This is you, this is me, when I'm plugging into my internal network at my company. The T1 contains the local administrators of the servers, well, pretty much the business servers. Sorry. And the T0 contains all the assets that are critical. If these assets are compromised by an attacker, the entire domain Active Directory domain will fall. And as you can see, I specifically put the domain admin users into the T0 as well as the domain controller, because if you own one of these things, you will be able to compromise the domain. Now, if you do that, what you need to keep in mind is that you must find a way to prevent domain admin users connecting to the T1 or the T0. Why? Because what I showed you the last 45 minutes is that as long as a domain administrator is connected on a server that a standard user can reach, if this server is compromised, you can consider that all the domain accounts that are connected on this server are compromised as well. So you don't want anyone who has high privileges on the domain to be able to connect here or here, okay? The last thing is I added a T-1 tiering model, part, which is which contains the ESXi, the vSphere servers, the backup servers. These are resources that must not be connected into the domain, the Active Directory domain. Why? Because let's say that you have your VMs running on a server that is connected to the Active Directory. If I own this account, the domain admin, whoever it is, if I own this account, I will be able to connect to the SXC account. And if I am able to do that, I am able to erase the VMs and erase the backups as well. So if you don't, well, if you do integrate the SXI servers into the domain, what I'm going to do is spawn this account and launch a ransomware that is going to destroy pretty much everything. Well, obviously, I'm not launching ransomwares for my clients, nor for anyone actually, but you've got the main idea. So yeah, final meme. If you guys work into, if you guys work as system administrators or pen testers in the future, keep in mind that you no one should have the right to use domain admin accounts to manage servers that are not domain controllers. Because as long as you do that, I will find a way. Personally, I will find a way to compromise these accounts and compromise your domain. That's pretty much it. I hope you liked it. If you've got questions, don't hesitate. And if you want to take a look at what I do as a researcher, you can take a look at this blog post. The last article I wrote was about writing your own antivirus and EDR. So I'm going to show you how, let's say, Sentinel-1, let's say, I don't know, Cortex, whatever, Kaspersky works, how it works, and how you can do pretty much the same thing using your own brain and some C code. That's it.
Anyone?
No question?
Anyone has any questions?
Good.
I have one on Twitch.
Yeah,
if
okay.
I can go for it. Someone is asking, can you explain, PS exec, please?
Okay. Let me show you something. So you will not be able to access this. Sorry for you guys. This is my personal knowledge base, in which I store pretty much everything I've learned in cybersecurity. So yeah, PS exec, how it works. Well, I'm gonna show you this screenshot, which is the most comprehensive one. Basically, what it does is it connects using the SMB protocol to the computer, and it's going to drop a file. This file is a binary. The next thing it does is it's going to connect to a name pipe called SVC Manager on the same computer. This name pipe allows the user to launch a service on the Windows computer. And in that case, it is going to launch the mdcwu zbv.exe, which is the PSExec server. The next thing is it's going to, when you launch, this binary, it is going to open ports, well, not ports actually, but it is going to listen on the network for incoming orders, which are basically the commands you want to launch on the server remotely. So if I wanted to show you more precisely how it works, so yeah, as I told you, the first thing is we upload the binary, which is a service, which is going to open something on the network so that you can send orders to the computer and receive the result back. The next thing is it creates a service. And once you've done that, well, it pretty much works that way. You send the who am I command over the SMB protocol. Since you've got a piece of code that is waiting for incoming orders, it is going to receive the orders via the SMB name pipe, execute it, and send back the results to your computer. That's the simplest way I can explain what PSExec is. There are quite a few resources that will explain you as well. The thing is, you need to have quite a high understanding of how Windows works and a few things about SMB name pipe and Well, most of all, the RPC protocol, which I'm going to, well, this is kind of a free publicity for me. But basically, if you want to understand how PSExec works, you need to read this. RPC is the most important protocol on Windows. It uses it all the time. And well, just take a look at it. If you need anything, any question, you can send me a PM on a message on Twitter. Otherwise, yeah, just read the blog post, and it will show you quite a few things, quite a few interesting things.
Well, thank you so much. I have another question from Twitch.
Yeah.
I'm a young intern in a big company and I need to understand RPC. Can you explain a bit what it is and how it works?
Well, read the article. Yeah, I can do that actually, but it's going to be quite a long explanation. Do I have the time?
It's all right, we just sent the link, so
Yeah.
they'll probably just read it.
Okay.
Well, thank you so much.
Welcome.